All right. Looks like a geometry question. Looks like a very happy guy here. In the figure below, AB is a diameter of the large circle. The center, C1 and C2 of the smaller circles are on AB. The two small circles are congruent and tangent to each other, and the larger circle is the circumference of the circle. C1 is 8 pi. What is the area of the large circle? I'm guessing this is an SAT question because they gave you the answers below.
Oh, yeah.
Those SAT questions. It's coming up.
Yeah, that was a little tricky. And I will say, like, this problem looks really complicated because of all the terminology in it. And just, it's like a paragraph, right? And it's really just asking the area. I will tell you, though, that a lot of this stuff is in there because you can't write some of these geometry problems without being very specific and making things very clear. One of the really important things about math in general, and I would say almost especially geometry when you look at these figures, is you cannot make assumptions.
Even if it looks like it's 90 degrees, it may not be.
Exactly, or if these circles look like the same size, we can't assume they are, or if they look like it's tangent. So a lot of this information is just verifying that you can solve it the way that you were taught, or that there is a method. Because if we didn't have, let's say, where we are, if we didn't know that they were congruent and tangent, then you could argue you can't solve this problem. You could argue, like, I can give you an estimate, I can give you something close, but I can't solve it. So again, all of this is very intimidating, but just kind of skim through it and think about what the problem is actually asking. And in the end, what we really want to know is just the area of the large circle. So I always like to start out with these by kind of skimming the problem. Like I said, what information is going to be important to me. And then I like to really focus on what the question's asking. And in my head, I usually work backwards on this. So what is the area of the large circle? So what I'm going to do first is think, well, what do I know about area of circles? Well, I know the area of a circle is pi r squared. So I'm going to go ahead, and you may see this notation sometimes where you see a little subscript, some small letters here. I put area, I put large in small letters there, subscripted, because I want to remember that this is what I'm going to use it for, the large circle. Now, in order to find this, the reason why I like to write this equation down before I even start plugging anything in is because it helps me identify what I need. And ultimately, I need to know the radius. If I knew the radius, problem's easy. I just plug it in, and then I'm done. And now in order to know the radius, we have to use some of the other information given to us. Obviously, that's not given, so we have to look at other information. So I skim this again. AB is a diameter. So I know that this right here is all the way across, and it's right through the center of the circle, so that helps me out. That tells me that if I knew the diameter of circle C1, I would know the radius of the large circle. So in my head now I'm thinking, how can I find the radius of circle C1? And as you kind of skim through this again, you see the circumference of circle C1 is 8 pi. So again, I'm thinking, what do I know about circumference? So I go ahead and I don't bother like plugging too much in. I just write circumference and then a little C1. That equation is 2 pi r. And I think, oh, that might be helpful because I need to know the radius, and maybe I'll be able to find that out. So we use this information where a circle of C1 is 8 pi, or the circumference of circle C1 is 8 pi. So we kind of come back here and say, okay, this equation, this is the equation right here for circumference, and I know the circumference over here, so we can substitute that value in. Circumference of C1 is given as 8 pi, right? That was right here. And again, I just like to rewrite this equation equals 2 pi r. And then think again, all we're looking for is the radius. That's what I'm looking for. And when we have 8 pi and 2 pi, we treat those as numbers because they are numbers. So we can solve like we normally would, dividing by 2 pi on each side. And I'm left with a radius of 4. Now, here's what I want to take a step back and just think about what this answer is or what this gives me, because especially if this is an SAT question, which it looks like, they do this because a lot of students will now, a lot of test takers will now be like, oh, I got the radius, let me plug it in here, right? And then you're like, I'm good, and I'd be willing to bet one of those multiple choice answers would be that mistake, which would be, is one of the answers 16 pi?
Let's find out.
Because they set these up to make sure that you can think through these problems
Yes, it is.
and reason them out, and
Oh,
they set them up.
those fake answers.
Yeah, so you make a mistake and you see that answer there, and then like, all right, I'm good. Let me move on, especially on a time test like the SAT. But think
So
about,
mean.
I know. But we got to think about what you found here, right? We found the radius of circle C1, right? We found this distance. This is 4. But we need the whole distance all the way across, right? This is what we need because the diameter of one of the small circles is the radius of that large circle. So if I know the radius is 4, the diameter, right, the radius on all sides is 4, so the diameter of the little circle is 8. So we know the radius for the big circle, I'll write it up here, is actually 8. And from here we just go and plug this back in, and we say the area of the large circle, I'll just keep writing this little subscript, equals pi times 8 squared, or 64 pi.
Which is number A, which is letter A.
Letter
So
A,
it is
right?
in there
So-
as well.
They give you a wrong answer that's tricky, and they give you a right answer. And there's probably a couple other answers that they know a lot of test takers make mistakes on, and they probably threw those in there too. So I would say with these types of problems, it's a little tricky. Try to think backwards, like what you're looking for, what you need, and then start thinking about other information kind of as a hint for like how you can find it. And then watch out for those tricks. Read that problem again before you select that answer, because almost every problem has some kind of trick to it.
Yeah, they're kind of mean that way.
Yeah.
They really do throw those in there.